All right. In the warm-up, we saw that the one way that we can write an equation of a non-vertical line is y equals mx plus b. Right? What would the equation of a horizontal line look like? I mean, just generally. Y equals b. This would be a horizontal line because the slope is 0. What would be the equation of a vertical line? X equals, we'll just say d. X equals some constant. That would be a vertical line. Okay, just quick review because I know you know that, but sometimes things slip our memories. All right, so we're going to talk about non-vertical lines right now. Every non-horizontal line is going to intersect the x-axis. Will you buy that? That someplace it's going to intersect the x-axis. And the angle formed where that non-vertical or non-horizontal line intersects the x-axis is called the angle of inclination. So we're going to see how we can find an angle of inclination. We're going to see how we can find the angle between two lines that intersect. But the angle of inclination, or the inclination of a non-horizontal line, just for a definition, so we'll all know what we're talking about, the inclination of a non-horizontal is the angle between 0 and pi, or 0 degrees and 180 degrees, measured counterclockwise from the positive x-axis. Measured counterclockwise from the positive x-axis. Okay, it has to be a positive angle. It's always going to be between 0 and pi, or 0 degrees and 180 degrees, depending on, I think in your lesson today, you're going to be asked to find in radian and in degree. So we'll have to get used to either going back and forth on the calculator or doing the conversion factor that we talked about. Yes, ma'am?
What does the last keyword say?
The positive x-axis. It gets a little sloppy when I get in a hurry, sorry.
For counterclockwise or
counterclockwise. Okay, so if we have, say we have a line that looks like this, that would be our angle of inclination. This would be our angle of inclination. It's measured from the positive x-axis. All right, now if we think about this for just a minute, let me change the color. We were going to find the slope of a line. Slope was defined as change in y over change in x, was it not? Slope is change in y. Delta just stands for change. Change in y, not x. Change in y over change in x. When we looked at the unit circle, how did we find the tangent?
sine over cosine?
Sine over cosine, or y over x. So would you buy that the tangent of theta is actually equal to the slope?
Yeah.
Change in y over change in x. Had you ever thought about that before?
No.
Okay, but there's a connection. Can you see that connection? The slope of a line is the tangent of that angle is actually equal to the slope of the line. Okay, because we're looking for that angle. So if we have, let's say that we have the equation the square root of x, or square root of 3 times x minus 3y plus 3 equals 0. That's going to cross the x-axis somewhere, and I want to find the angle of inclination. So if we know that the tangent of theta equals the slope, we can figure out what the angle of inclination is. Either it'll be an angle we know, or we can figure it out. We can figure out what theta is using our calculators. But the first thing I need is slope. So we can solve this equation for y. We'd have negative 3y equals negative square root of 3 times x minus 3. So y is equal to the square root of 3 over 3 x plus 1. So what is my slope?
Square root of 3 over 3.
Yay, Aiden, you remembered. You said slopes give you trouble.
They do.
I'm just giving you a hard time. So that means that the tangent of theta is the square root of 3 over 3. What angle has a tangent of a square root of 3 over 3?
Pi over 6. Pi over 3.
That would be pi over 6 if we're in radians, or 30 degrees if we are in degrees. So we just found that angle of inclination. That happened to be a value that we knew. Yes, sir. Okay, we want to find the angle of inclination that this line makes with the x-axis. So, what do we think what you have to do first? I need a calculator on this one, I think. What's our slope?
5.
All right. Also, if we think about the standard form of an equation, ax plus by plus c equals 0, if we were to solve this, we'd have to subtract ax and then divide by b. So you can look at an equation and recognize, hopefully, that the slope is negative a over b, without having to solve the whole thing. So here our slope is 5. That means that the tangent is what? Is that a value we know?
No.
No, so you have to use your calculator. So let's do it in degrees and radians. I think.
Wait. Do we use arctan or tan?
If you're looking for the angle, you always have to use the arctan. Okay, so what is it in, let's say, has anybody got it in radians?
I do.
What'd you get in radians?
1.373.
1.373. Now, you can either re-input it, or how would you convert to degrees? Times 180 over pi. You can do that too. That way you don't have to constantly be going back and forth on your mode. So you can multiply that by 180 and then divide by pi. And that should give you 78.69. That just saves you a little bit of time as far as changing your mode.
So radian to degrees is what?
180 degrees over pi. If you're trying to get rid of radians, you divide by pi. If you're trying to get rid of degrees, you divide by degrees.
I remember this.
Okay, so we're getting some review. Find the slope of this line. What's the slope here? Negative 2 over 3. That means that, and then it's going to look something like this. Is that right? We have a negative slope. So the angle is going to be here. Does that make sense if we think about the fact that the tangent is negative? Is the tangent negative or positive in quadrant 2? It's negative. Okay, what happens though when you plug it into your calculator? What do you get? You get a negative angle, don't you? When you plug it in your calculator, you get this negative angle. So how are you going to change it to a positive angle?
Plus 180?
No. That's
Okay,
degrees.
you said 360, you said 180,
180. Because
I say 90.
and Aiden says 90.
I say 45.
360 degrees is going to take you
back.
from here all the way around, back to where you were. What do you get? Because we need an angle is measured between 0 and pi, or 0 degrees and 180 degrees. So we need to add 180 degrees. Okay, so or if you're in radian measure, you add pi. So in this case, theta is going to be equal to basically pi plus the arctan of a negative 2/3. Whenever you have a negative slope and you're trying to find the angle of inclination, you're going to have to add pi radians or 180 degrees to get you to the right spot. Does that visually make sense to us? Okay. So in this case, what is our angle of inclination? We'll do radians first. 2.554, and then if you multiply whatever you got by 180 over pi, what do we get in degrees?
146 degree.
146.31 degrees.
Yeah.
Okay.
Yeah, it's going to be negative.
And when you plug it in your calculator, you're going to get a negative angle.
Oh, yeah, okay, got it.
All right. So does that make sense to us?
Yeah.
All right. You try this one. Here's our equation. X plus the square root of 3, y plus 2 equals 0. So what is the tangent of theta?
Negative square root of 3 over 3.
Yeah, I got that.
Okay. Now this one, since you're not using your calculator, you could probably figure out, but if we're thinking arctan, what are we going to get? What's theta?
5 pi over 6.
Okay, but what do you get if you were thinking arctan? You'd get a negative pi over 6 plus pi. And you are right, it is 5 pi over 6. And what is 5 pi over 6 in degrees? 150 degrees.
Yay.
Okay, so not too bad. We just have to remember if we have a negative slope, you've got to add pi to whatever you get when you use the arctan. All right, if you have two lines in a plane, you've got two options. They're either going to be parallel or they're going to intersect somewhere. I think they're either parallel or they're going to intersect. If they intersect, say this is, well, let me just do this. Say they intersect, we're going to have two pairs of opposite angles, don't we?
Yes.
One pair's acute
One belt.
and one pair's obtuse. The acute angles are what we refer to as the angle between the line. The acute angle is the angle between the line. Between the lines. And we can use the idea of angles of inclination to help us determine what the angle between the lines actually is. Now, let's say that I have theta 1. This is the angle I'm going to be looking for. We'll say this is theta 1 and this is theta 2. What do we know about this angle right here?
Right?
The little pink one right here. What is this angle?
same.
It's also theta. All right. Let's think back to geometry. A lot of ways you could get this, but we have a theorem that directly helps us.
Oh, gosh, I don't know these.
So this is a good review, isn't it?
Data
Alternate interior
2
angles.
equal data 1 plus data, right?
Say that again?
Data 2 equal data 1 plus data.
Good. The outside angle is equal to the sum of the remote interior angles. Now you could use the fact, you could figure out what this unknown angle is, 180 minus theta 2. Then they all add up to 180, which gives you theta 2 equals theta 1 plus theta 2. So we know that this is, but the theorem makes it a little bit easier. So if we want to solve for theta, theta is equal to theta 2 minus theta 1, right? Everybody buy that?
I buy it.
Good. Okay, so now what I'm going to do, see if we can figure out how to find that angle. That's not real helpful. I don't have a formula yet. But if I take the tangent of both sides, because tangents and slopes have a relationship. The tangent of theta equals the slope of the line. The tangent of theta is equal to the tangent of theta 2 minus theta 1. And I have a formula for the difference, the tangent of the difference of angles. It's equal to the tangent of theta 2 minus the tangent of theta 1 over 1 plus the tangent
This looks familiar.
of theta 2 times the tangent
Wait, what
of
is
theta
this?
1. That is the formula for the difference using tangent, the difference of two angles, the
Oh, okay.
tangent, the difference of two angles, the tangent of the difference of two angles. All right, but that looks kind of cumbersome.
It looks.
Yeah, just a tad.
Yeah, so we know that this angle has to be acute because we said it was the acute angle. So what does that tell us that the tangent's going to always be? Less than 90, but it's always
Below
positive. That's what I was looking for. It's positive. So instead of using this formula, would it be okay to say that the tangent of theta equals the absolute value, which gives me a positive, of the slope of line 2 minus the slope of line 1 over 1 plus the slope of 2 times the slope of 1. Okay, just a substitution, because we said the tangent of theta equals the slope. Okay, I use the absolute value simply because I know I have to have an acute angle. So, and that also helps us. We don't have to be extremely concerned with which one's line 1 or line 2, because when you take the absolute value, it takes care of the situation. All right, what would happen if the lines were perpendicular?
Well,
Equal like 1 or...
the data is 90 degrees.
Theta is 90 degrees, so what would I get right here?
Undefined.
Undefined.
Very good, Aiden.
Yes, because if we think about pi over 2 on the graph of the tangent, we have an asymptote.
Yeah.
Think so. Those graphs help me so much in learning in some of those quadrantal angle values. Thinking about what the graph looks like, I can immediately tell what's the value. Okay, so let's look at an example using this formula. All right, we've got line 1 is 2x plus y equals 4. And line 2 is x minus y equals 2. So what is the slope of line 1?
Is that a 4?
Yes.
-2.
The slope is -2. What's the slope of line 2? 1. So now we just plug into our formula.
It's -1.
No, it's just
Positive
positive.
1.
Negative A over
Oh,
B.
yeah, it is 1.
Remember slope, shortcut, negative A
Oh, yeah.
over B. So the tangent of theta is the absolute value of 1 minus a -2 over 1 plus -2 times 1, so that's going to be minus -2, or, well, we'll say plus a -2, how about that? Just to be, so the tangent of theta is the absolute value of 3 over -1, or 3.
-3.
Tangent of theta
Oh,
is
yeah, it's
3. We
absolute
have to take the
value.
absolute value. And so, what is theta?
1.249.
That's radians. What is it going to be in degrees?
71.565.
You just eyeball it.
Just eyeballing it.
0.57.
Okay. Okay.
I did really have to.
Find the angle between the lines. If these are the two lines, you find the angle between those two lines. Get in radians.
Not a good one.
How do you know?
I trusted it.
Sophia? Come on.
Come on, Sophia. You can do it.
Probably did, but I got 0.464.
464?
Good.
Wow.
Is that right?
No.
No.
Wait, what?
I heard 1.391.
I did not
Oh,
get that. I did not
I got
get
like
that.
point.
I got, no, wait, did you get 0.896?
No.
I got 0.942.
Wait, is that the right answer?
1.391.
Is that the right answer?
I got that.
And what is that in degrees?
6.955.
What were the two slopes?
I got literally.
Oh, okay, this-
Wait, what was the answer?
2 and -3/4.
Same.
Yay!
Wait,
How
I
did you
did
Wait,
it.
Miss Scoville.
I did
What
it.
happened?
Look, digging for the right line.
Okay, there's your slopes.
So what did you get for the tangent of
Oh.
theta?
2 and
Yeah.
-5.5.
I think it's 11 halves, 5.5. The tangent of theta ends up being
I'm just gonna lie.
11 halves.
Wait.
You'd have
There was no error.
the tangent of theta is equal to the absolute value of -3/4 minus 2 over 1 minus 3/2, because 2 times 3/4 is going to be 3/2. All right, so on top, you can do it in decimals if it's easy. -11/4 over -1/2.
What did I do wrong here?
Keep change, flip, and you get 11 halves.
What? I got 1.
All right, we want to find the distance between a point.
Did we do this in,
Oh, wait.
we already did this, right?
No.
No, we haven't done
The distance between a point, let's just say x1, y1, and a line. And the line is in standard form, ax plus by plus c equals 0. The distance is the absolute value of a times, we plug in the values for x and y in our point, plus b times y sub 1 plus whatever the constant is over the square root of a squared plus b squared. To find the distance between the point 0, 2 and the line 4x plus 3y equals 0. So that distance is going to be equal to 4 times 0 plus 3 times 2, and there is no constant, over the square root of 4 squared plus 3 squared. So that's going to be equal to the absolute value of 6 over 16 plus 9 is 25, 6/5. 6/5 is the distance between that point and that line. Okay, I want to find the distance between the point 4, 1 and the line y equals 2x plus 1. What do I have to do first?
You have to put it in standard form.
Put it in standard form. ax plus by equals c. So this is going to become negative 2x plus y minus 1 equals 0. Generally, we don't like that first number being negative, but since we're taking the absolute value, it's not going to matter here.
Why not just move the y to the other side?
You could.
So it's 0 equal to x minus y.
You could. You can do that too. Distance equals absolute value, negative 2 times 4 plus 1 minus 1 over the square root of negative 2 squared plus 1 squared. So these cancel.
Wait, I thought it was plus 1 times negative
Minus 1. Plus 1 minus 1. So here we're going to have 8 over the square root of 5, which Stinkai is right, is 8 square roots of 5 over 5. Okay, we have a triangle with vertices at the point A, and the point is negative 3, 0. The point B, which is 0, 4. And the point C, which is 5, 2. And we want to find the altitude from B to side AC. That's the first thing. I want to find the altitude, or the length, the distance. The altitude from point B to side AC. And then I want to find the area of the triangle. Okay, so let's think about this. I'm just going to kind of briefly sketch. If we think negative 3, 0, and then 0, 4, here's A, here's B, and C is maybe right here. So here's our triangle, more or less. It's hard to draw these on here. Okay, I want to find this distance. So what do we need to find the distance from a point to a line? We have a formula, but what do I need before I can plug into the formula?
Your base?
The line.
I need the equation of the line. Okay, now if we have 2 points, the points A and C, I can find the slope and then I can find an equation for the line. So the slope of line or segment AC is going to be change in Y over change in X. 2/8 or 1/4. We good there? There's your slope. Now you can choose either point. A or C to find the equation of the line. If you have a value of 0, that's probably going to be the easier point to use. So we know that y minus 0 is 1/4 times x plus 3. And I don't know why I put a negative there. There's no negative there. So if I multiply both sides by 4, we get 4y equals x plus 3. And we can say that x minus 4y plus 3 is the equation for the line. Or you could move everything to the other side. It doesn't matter. Okay, so now we have an equation of a line, and we have a point. Our point is the point 0, 4. So we can use our distance formula. Distance is equal to the absolute value of 0 times x minus 4 times 4 plus 3 over the square root of 1 plus 16, a squared plus b squared. So we have the absolute value of negative 16 plus 3, which is negative 13, over the square root of 17, and this will be 13 over the square root of 17. So the distance is 13 square roots of 17 over 17. And we're going to use this number again, but I'm going to use it in the unradicalized form. All right, but that's the length of the altitude.
It's like how long the line is.
How long that line is, yes.
Wait,
That pink line, how long that pink line is from B to side AC. That's the length of the altitude. That's the height of the triangle.
So
Yes.
there is a formula to find distance between 2 points, right?
Yes, there is to find the distance between 2 points, but we don't know where the altitude is going to hit there.
Oh,
So we've got to just find the equation for the line, because now we have an equation or a formula for the distance between a point and a line. We don't know where it's hitting right here, because the altitude is going to give us a right angle.
yes.
Okay, so now we have that distance or that height. I want to find the area of the triangle. And to find the area, it's half the base times the height. We have the height. We got to find the length between A and C. And so that formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. I think we might have talked about this last week when we did the SAT review. So we can plug into that formula. Distance equals the square root of x2. 5 minus a negative 3 is 8 squared plus 2 squared is equal to the square root of 68, which is 4 times 17, or 2 square roots of 17.
And what is that?
So we said area is half the base, which is 2 square roots of 17, times the height, which I'm going to use the 13 over the square root of 17 instead of the radicalized or rationalized form. Because now we see the 2's cancel and these cancel, so the area of that triangle is 13 units squared. So we had to find, first we had to find an equation for the base so that we could find the distance. And then we had to find the length of the base so we could find area. Okay. So your assignment is on page 730. I have it written down. 8 to 44 every fourth. 51 to 60 every third. And then 62, 65, 66, and 67.